Hello friends, so here is another question on description of motion. So it is given that an object, it covers the first one third of its journey with speed small u, the next one third of the journey with speed v, and the last one third with speed w. Calculate the average speed of the object for the entire journey. Okay, so let us say that an object, it starts from a certain point, okay, and it covers three different you know three different phases of the journey of equal distances covered in each. Okay, let's say we divide it into three phases. The distance is the same, this. Okay, let all of them be x kilometers or x meters, whatever, only x, because no units has been given, so only we'll call it x. Okay, all are equal distances covered. This is the first phase, this is the second phase, this is the third phase. Total distance is 3x. Okay, the total distance is 3x. This is the first one third, this is the second one third, this is the third one. The speed in this phase is u, the speed in this phase is v, the speed in this phase is w. This is the distance, okay, x. So we know that average speed is equal to total distance by total time. So here we have the distance with us, okay, 3x, the distance of the three individual separate phases, okay, and we have the speed in the respective phases. So we know that the time is equal to distance by speed. So the time required in each of these phases, separate phases, they will be, simply we will divide distance with speed. So the time in the first phase is equal to the distance covered in that phase, which is x, divided by the speed u. The time in the second phase, t2, same distance covered, x by speed v. The time in the third phase is the distance covered in that phase, x divided by speed w. So here the total distance covered is equal to 3x, that is the total distance, and total time here is equal to x by u plus x by v plus x by w. Okay, so t1 plus t2 plus t3. So if we take u, v, w as the LCM, so it will be equal to, if we take x common here it will be equal to 1 by u plus 1 by v plus 1 by w, this. So this will be equal to ubw, will do that, and it will be equal to vw plus uw plus uv. This is the total time, x into ub plus vw plus uw by uvw. This is the total time taken. So the average speed expression, it will be the total distance covered is 3x divided by the total time is x into uv plus vw plus uw by uvw. X gets cancelled and this is equal to 3 uvw by uv plus vw plus uw. So always remember this formula, okay? So if you have a question where you cover equal distances in 3 or 4 in whatever separate phases you have, there are with different speeds, okay? So the average speed for the object of the entire journey will be this, okay? You can directly use the formula, but otherwise you can go conventionally. Always remember this is the basic formula, okay? This, then time is equal to distance by speed, distance is equal to speed into time. All that interchange you can do, all you can get from this basic formula, and then according to the conditions, according to the the nature of the question, you can put the respective values to get the desired result. Okay, so this is the average speed for the entire journey. So here is another question. So it is, I think, quite the opposite of the previous one, but okay. So it is given that the car is moving in the positive x direction and the velocity of the car is 20 meters per second. Again, it comes up behind a truck and is unable to pass, so it slows down to 15 meters per second. And all this happens within a time duration of 2 seconds. So we have to calculate the car's average acceleration. So here the velocity is decreasing. So here again average acceleration is final velocity minus initial velocity by final time minus initial time, which is basically change in velocity by change in time. Here final velocity, it is slowing down, so 15, initial velocity is more, which is 20, time duration is 2. So it is minus 5 by 2 equals to minus 2.5 meters per second square. Here it is negative because velocity is decreasing. Okay, at the rate of 2.5 meters per second. So every 1 second the velocity is decreasing by 2.5 meters per second. So in 2 seconds it decreased to 15. There is a 5 unit or 5 meter per second decrease in velocity. In the previous case it was plus 2.5 meters per second square. So it was increasing every 1 second 2.5 meter per second. Okay, so here it is deceleration or negative acceleration. Okay.